who doesn't like rockets? I mean, they're huge machines that spit fire and carry things into space. For a quite long now, SpaceX has been making the news with their Falcon family of rockets. And they landing their boosters? Well, it has become something that we take for granted. But remember, these amazing machines are the size of a 21-story building. These animations, by the way, are made by the Corridor Crew people. You should really check their video, link in the description below.
Rocket development began in China around the 2nd century with the invention of some precursor of gunpowder. Years later, around the 9th century, they started developing proper gunpowder, and then the fire arrows were invented. These were just arrows which were propelled extra distance by the use of a rocket motor. Eventually, these fire arrows will develop into proper rockets. In fact, in 1245 was the first recorded use. The Mongols were in China around that epoch, so they knew the technology, and when they came to Europe to conquest, they brought it with them. It finally became well known in Europe with the siege of Constantinople, but in reality it will be just a curiosity and never will be used in large quantities in warfare or any major conflict. Later on in India, the British Empire will face the Mughal Empire, who will use iron-cased rockets. They will get impressed by the use of this weapon, and they will start developing them with a more scientific approach. In fact, they will be used against Fort McHenry in the United States, and there is a reference to it in the USA anthem.
And around the year 1900, the first major change appears. A Russian school teacher, Konstantin Tsiolkovsky, developed this following equation, which nowadays is called after him, and states that the range of the rockets is dependent only on the exhaust speed, and proposed the use of liquid fuel for greater efficiency. A decade later, an American called Robert H. Goddard started experimenting with rockets. Eventually, he built the first successful liquid-powered rocket.
Finally, with their V2 bombs, Nazi Germany will be the first to reach space with a rocket. Okay, but what do you have to do to be in space? You have to reach the altitude of 100 kilometers. This is where your orbital speed is lower than the speed required to produce aerodynamic flight. But going up is not the full picture. In fact, if you want to get into orbit and not just to space, you have to go sideways and at a very high velocity. To reach these huge velocities, we have to do some tricks. The main one is called staging. By dividing our rocket into smaller pieces, we can produce more change in velocity and therefore get higher and faster. This example that you are seeing now is one of the most famous. It's called the Korolev Cross, and it dates back from the 1960s, but today is still used in the Soyuz family of rockets. There are several types of staging. The most common are the serial staging, which is what the Saturn V used, and the parallel staging, which Soyuz uses. Also would be engine staging, where you drop just the engines to reduce the mass, and tank staging, where you use drop tanks that will be discarded. In order to propel the rocket, we have several types of propulsion. The main one, the most common, and all the examples that we have seen so far, is what is called chemical propulsion. It can be further divided into solid, liquid, and hybrid propulsion. Solid propulsion is the simplest and cheapest of them all. That's why this is what it was used in the beginning. It packs in the same solid substance the fuel and the oxidizer required for the combustion. Liquid propulsion is much more complex. This is because it requires systems to feed the engine with the appropriate mixture of fuel and oxidizer. But this complexity is rewarded with an increase in efficiency. The last type of chemical rockets are the hybrid ones. Those have a solid core through which is pumped a liquid oxidizer. This system is said to have all the complexity of a liquid one without the advantages of it. Therefore, is not commonly used in commercial rockets, and its development has been made mainly by amateur rocketeers. Nevertheless, other concepts have been proposed. Nuclear thermal rockets have been studied for upper stages, where a nuclear reactor heats a fluid, expanding it and therefore generating thrust. But the craziest idea of them all was developed in the nuclear age. It consisted in exploding nuclear weapons behind the rocket as a means of propulsion. They even tried it with conventional explosives to demonstrate the concept. and what happens when something goes wrong. Engineers have thought about it. If the vehicle goes off the course, they usually have termination systems that will destroy it. And usually, when there's people on board, rockets will carry an abort system. This will separate the crew capsule from the rest of the rocket, ensuring their safety. Okay, now you're in space, but you want to go down. First, you have to slow. The fastest method is using a rocket, but it requires fuel. In order to avoid carrying large amounts, you could use the atmospheric drag to help, although this method has the problem of inducing high temperatures in the vehicle, and therefore you will have to take it into account. A while after re-entry, you will have to land, but you are going too fast. How to reduce your speed? Well, until a few years ago, the most common method was using parachutes. But SpaceX and Blue Origin have popularized the propulsive landing method, and for this also exists two schools. If you can throttle down your engines enough, you can perform a hover landing. This is what Blue Origin does. If not, you can do what is called a suicide burn. This is the method used by SpaceX. This means that you kill your vertical velocity at the same time as you touch the ground. I'm sure you will be able to guess why it's called in that way. If you are interested in the topic, I highly recommend you Kerbal Space Program. This is a video game about little green men where you can build your rockets and explode them and learn about orbital mechanics and how they work and how to get into orbit and some of the problems that will arise by trying to do those things, and which has lots of tutorials in YouTube where you can learn how to play it. Also, I highly recommend you the channel of Scott Manley, which talks about space related topics, and as he says,